Hey everyone on YouTube, how is it going? This is Micah coming to you from out of here in Philadelphia. Just wanted to take some time. This is actually going to be for the content for my new channel starting. But what I want to do on this channel is basically start with a couple of subjects and then just go from the beginning, go all the way through them. I think on my other channel I'm doing algebra. On this channel I think I'm going to go ahead and start with microeconomics and then just economics in general. Kind of make this the focus of this channel. So anyways, one thing about micro, and this is like when I first started when I was in college, the very first lesson, and this is going to be calculus based microeconomics, by the way. One of the first things that we did was a review. So initially, we kind of just started off going over some basic principles that you learn in like calculus 2. And periodically, you are going to see me wipe my head because it is pretty warm outside right now. I think it's like 76 degrees in my place, and like it's just, what is it, May? It's May 26th. We're heading into June soon. So yeah, temperature is climbing fast out here in Philly. So anyways, like I said, we'll get right into it. I want to just start off with some basic rules that you probably have seen before if you have taken calculus 2. The first rule is going to be the constant rule. So we have a function, for any function f of x in which k is equal to some constant. The rule states that if we take the derivative of this function f with respect to k being the constant, derivative of that function is going to be 0. Okay, so that's pretty straightforward. And then also we can expand on that a little bit further by just taking, because we can also do the constant multiple rule. Really quick, it just states that if you take the function of x and you have that equal to another function k times k being the constant, g of x, that being another function, then the derivative of x, so derivative of this function, with respect to x, and actually, yeah, I'm glad I said that actually. My apologies. This actually should be x. Yeah, we're not taking it with respect to k. We're taking the derivative of the function with respect to x. So the derivative of this function with respect to x is equal to k times the derivative of g of x. So derivative of g with respect to x. And so this is a constant rule. We'll just put CR. So this is a constant rule. This is the constant multiple rule. Okay. Pretty straightforward so far. So we covered those. So what we'll do next is go over the sum and difference rules. So what we want to basically, we'll just do we'll do the sum rule, and then later on we'll do the difference rule, because I mean they're pretty much the same thing. And I'll explain. It's just one is with addition, one is with subtraction. That's pretty much the only thing that's interchanging. So what the sum rule, so basically the sum of two functions in calculus, basically what it states is that f of x is equal to g of x. Well, when f of x is equal to g of x plus j of x, the derivative of f, so derivative of this function with respect to x, is equivalent to the derivative of g with respect to x plus the derivative of j, the derivative of j with respect to x. It's my timer going off. Take some medicine. Having issues with my tooth lately. Personal problems, completely on another side tangent. Going to the dentist tomorrow for that. Thank the Lord. But anyways, okay. So this, the only reason I said this, it's not really necessarily. We're not going to show a whole nother example for subtraction or the difference. It's literally we would just do the same thing. The same property applies if you use subtraction. Like if you interchange that addition with subtraction, literally the same thing. Okay, so the next one is the power rule. Now this one is super important because especially in microeconomics, like I mean, a lot of the derivatives that we're going to be doing involve the power rule. So if you can't like instinctively see the power rule in a lot of the problems and like just be able to do it almost like it's like second nature, you're going to have a lot of problems in calculus-based microeconomics. So what I would suggest is if that's like a weak area, take some time, a couple of nights, like especially if you're just coming into the course, just double down. Don't go out, don't go drinking, don't party. Just focus on like reviewing your calculus. If you took calculus in high school, or even if you're taking them concurrently, which I would definitely not recommend in college. I mean, like unless you're really, really good at math and you pick up on things super fast. Like my sister was a pure math major, so she like for her taking calculus and like a calculus based course, that was nothing to her because like she was just really good at math. Like if that's you, then absolutely by all means, hey, don't let me tell you what to do. But if that's not you and you're like me and you are the kind of person who needs to have the foundation and then build on that foundation, then yeah, I wouldn't recommend taking calculus and calculus-based microeconomics at the same time. So anyways, enough of my little spiel. So now to the power rule. The power rule states that for any function f of x, where x, well, which is equal to x to the n, assuming that n is not equal to 0, we know that the derivative of f with respect to x is going to be equal to, so what we're going to do is take that n, this number n, bring that down here in front, n times x up to the n minus 1 power. Okay, so whatever this is, so like if this is a 3, what you would do, and I'll just, for an example, let's just say the derivative of 3x. What we would do is just take that 3, we move it down here, and then subtract 1. So the derivative of x cubed, I said 3x, x cubed would just be 3x squared. Okay, super simple. And I'm kind of running out of time. I did want to get both of these rules in, but I think I'm just going to do, because I mean they're both really important. The product rule and the quotient rule are like very, very important. But I just don't want these videos to be too long for this series. Because I like it better when we have it broken down in like bite size. You know, like that way I'm not bombarding too much on you guys. You know, you get a little bit, study, use it with your homework assignment, then come back and we move forward from there. So so for the product rule, I'll go ahead and I'll post this one. I'll say I'll do this one and then try to get in the quotient rule. So for the product rule states that the derivative with respect to x of the two functions f of x when multiplied by g of x is equal to the derivative, and now make sure you pay close attention because this is like literally this always got me on exams. Like I would switch these two and my professor would be like you had the right answer, you did the product rule wrong, like the easiest part of the equation you did wrong. And I'd be like, oh man, he's right. Like I would switch them. Like I would do, and I'll show you. So the derivative of, I'm getting way too excited because this is just kind of bringing me back to my college days. The derivative of x, the derivative of f with respect to x times the function g. So you don't want to take the derivative of g with respect to x times g of x. You want to take the derivative of this first equation times the second equation, and then you're going to take that and you're going to add that to the first equation. So just f of x times the derivative of g with respect to x. Not vice versa, not both of them at the same time, not the derivative of g plus the derivative of g. Like I said, I've seen all kind of mistakes. I've made this mistake. It's just like, I mean, it's, you just don't want to make, you want to make sure that you have this on this really locked down, because if you go through an exam and you do this, it's going to completely, you're going to lose probably like half the points on the problem because of something. And I'll show you exactly what I've done. I've done the derivative of g with respect to x plus g of x. And I literally added that to the derivative of x, to the derivative of f with respect to x times f of x. And I was like, and I literally would sit there for like 10 minutes on an exam, like why, like I know like the answer I'm getting isn't right, and I would be like, what am I doing? And then like after the test was over, and you know, instead of getting an A, I get like a B. The professor would be like, yeah, I mean, like I couldn't give you full credit because you didn't get the product rule right. Like I know that you knew what you were doing, like in regards to the sequence of the problem, but you messed up on, you know, basic calculus. Like I can't give you full credit. So, and understandable, that's what college is about, learning, you know, the devil's in the details. So actually I missed the parentheses right there, speaking of details. And so lastly, the last thing we'll cover the quotient rule, and then I'll stop rambling on about my college days. Was fun. They were amazing days. I went to Towson University, great school. I would recommend it for anyone. Anyone. I mean, if your major happens to be something that is offered at Towson University out of Maryland, it's right outside of Baltimore, Maryland, I definitely would recommend that school. Great school. Shout out to Dr. Christensen and Dr. Matthews. So anyways, f of x is equal to, in this case, we're using mu. So mu of x over v of x. And keep in mind, this is this right here. This is the product rule. Oops. What we're doing right now, this is the quotient rule. So it involves division. This is when you have two equations that are multiplied. This is when you have two equations that are being divided. So when you have mu of x divided by v of x, taking the derivative of f with respect to x. This one is a little bit trickier, but once you do it a few times, you get used to it. So the derivative of f with respect to x when f of x is equal to mu of x over v of x, that is equal to the derivative of mu. You could just say u, but anyways, that's how I wrote it down in my notes. D of x times v of x, the function v of x, not the derivative. Then you want to take that and subtract that. This will minus u of x, or mu of x, times the derivative of v with respect to x. And then you want to take all this and divide that by v of x squared. And this, ladies and gentlemen, is the quotient rule. So let me take a look at my notes. We also have 2 more rules, but I mean, like, I think we're pretty much running out of time. I'll probably post those after. I'll probably do another short little video with the last 2 rules. It's the chain rule, and yeah, literally, it's just a chain rule. And then I think I have an example here of doing another derivative with radical functions, in regards to the differentiation. So, like I said, I'll take a pause there. I think we got pretty good for the basics, and then yeah, I'll catch up with you guys later. Okay, everyone, have a great day and stay safe.